everyone, this is Ms. Helms, and what we're going to show you is how to factor trinomials with a leading coefficient other than 1. So, just as we have done with factoring trinomials, our first step is always to look for the greatest common factor. So we're going to look for the greatest common factor of 10n squared, negative 13n, and positive 4. However, there isn't a greatest common factor. Our greatest common factor is only 1. So therefore, we're going to move on to the steps that we would normally take to factor a trinomial. So first step is to determine our a, b, and c value. So our a value is positive 10, our b value is negative 13, and our c value is positive 4. Then we're going to go ahead and put that into our x. Remember, at the top of the x, we say, well, what multiplies to a multiplied by c? So 10 multiplied by 4 is 40, but adds to our b value, which is negative 13. So what factors of 40 add to negative 13? That would be negative 5 and negative 8. Negative 5 multiplied by negative 8 is positive 40, and negative 5 plus negative 8 is negative 13. Then we're going to use our box method. So go ahead and create your box. The top left of our box, we put our first term, which is 10n squared. And the top right of our box, we put our c value, or our third term, which is 4. And on the left-hand side of the box, we put the two numbers that we determined from our x. So that would be negative 5n and negative 8n, because that's what's going to determine our middle term. So now we're going to find the greatest common factor using this greatest common factor box. So what is the greatest common factor between 10n squared and negative 5n? Well, that's 5n. What is the greatest common factor between 4 and negative 5n? That's going to be negative 1. Remember, you always want to use the same sign in the second column as the sign of the term in front. Coming down, we've got what is the greatest common factor of negative 8n and 10n squared? Well, that would be 2n. And what is the greatest common factor of negative 8n and positive 4? That's going to be negative 4, because our signs match. Now we have our binomials of what we factored this trinomial into. So our two binomials would be, if we look at our diagonals, 5n minus 4 times the quantity 2n minus 1. Remember, it's very important to find the diagonals, because if you do not find the diagonals, you're not going to get the right answer. So our last step is to check our work to make sure we did this correctly. So to check, we would multiply our two binomials together. So we've got the quantity 5n minus 4 times the quantity 2n minus 1. So we're going to use double distribution to expand and multiply these binomials. So 5n times 2n is 10n squared. 5n times negative 1 is going to be negative 5n. Negative 4 multiplied by 2n is going to be negative 8n. And negative 4 multiplied by negative 1 is going to be positive 4. Our last step is to combine our like terms. So we would get 10n squared minus 13n plus 4, which verifies that we did it correctly because that was the original trinomial that we came up with.